Hola, soy Dora.
And I'm Boots.
And we're here to learn about the quadratic equations.
Yeah.
We're on our way to school to pass our homework about the application of quadratic equations.
Do you guys hear something?
Wait a minute, I hear it too. That sounds like
Swiper! I'm gonna steal your homework.
Swiper, no, Swiper.
You're too late.
Oh no, our homework.
What should we do?
We should ask the map for directions to Swiper's house.
That's a good idea. I'm the map. I'm the map. I'm the map. I'm the map. The map, and I'm here to help you find Swiper and your homework that he stole.
Where do you think Swiper's house is? That's great.
Go.
I think that's quadratic near the lake.
Let's go.
Oh no, it looks like Swiper put some drops in the quadratic near the lake.
How will we get it? With all these turtles? I think we should feed it. We found it! A piece of the paper! Not the whole paper!
Is launched directly upward at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height at time seconds after launch is s times t is equal to negative 4.9 t squared minus plus 19.6 t plus 58.8, where s is in meters. When does the object strike the ground?
We should ask the backpack for help. Backpack. I'm here to help. Yeah! We should go to the solution forest. We can find another piece of homework there. I think that's a great idea, right?
Yeah.
I think that's already solution forest. Let's go.
Let's go. There's so many leaves everywhere.
How are we gonna find it? Here, you can use that paper detector. Go. Wow, a paper detector.
Thanks, backpack.
We did it. We found the solution.
Good job, Boots.
Good job, Dora. Okay.
In quadratic equation problems is RESCA. It stands for representation. Thing we have to do is the representation, and it is what would x be equal to, and we have to determine their values using x. Since it's easier, we are going to use t because we are looking for the time the object would strike the ground. So we first have to recall the formula here for using it. It is s, the height at the particular time, and then t, of course, is time. So it's just like height at a particular time. So the formula there is negative g squared plus VOT plus HO, and we're going to use this as a basis for our representation and therefore our equation as well. And we can see here on the down rightwards of the screen, STG is the gravity value. In feet, this value is 16, and in meters, it is 4.9. That's why we will be using negative 4.9. VO is initial velocity, and HO is the initial height. So using these terms and getting the values from our problem, it is going to be equal to negative 4.9 t squared plus 19.6 t plus 58.8. For our solution, we are going to turn that into general form. So from the original equation, we're going to divide all sides by 4.9, making that to t squared minus 4t plus minus 12 is equal to 0. So yes, that is a 0, not the O is different from the 0. Just so we can put that in general form, then we are going to factor that. So it's going to be factors of negative 12, that will add up to negative 4. So that is t minus 6 and t plus 2. Once once changed to sign, it's going to be, because we equate it to 0, it is going to be t is equal to 6 or t is equal to negative 2. Since there is no such thing as negative time, we won't be considering negative 2 but just 6. So the object strikes the ground 6 seconds after the launch. We're going to check this now, where we're going to plug in the value of t, which is equal to 6, into our equation. And the end goal of checking is to derive at a true statement so we know our answer is fully correct. It's much easier to use the equation in general form, and we end up arriving at a true statement anyway, but I'm just going to show you. So the original equation is t squared minus 4t minus 12 is equal to 0. Instead of using t, we're going to put 6. So it's going to end up being 6 squared minus 4 times 6 minus 12 is equal to 0. So 6 squared is 36. 4 times 6 is 24, keeping the same sign, and then 12 is as is. So 36 minus 24 minus 12 is all equal to 0. So since that is a true statement, our final answer really is that the object strikes the ground 6 seconds after the launch.
We have to be really, really quiet so that we can get the paper out of Swiper's hands, okay?